6.5, solve absolute value equations. All right, so this is gonna have between like today and tomorrow, this is gonna have a lot of similarities with the stuff that we've been doing. Obviously, we've been doing inequalities. Okay, so these two sections, 6.5 and 6.6, go together. This is absolute value equations. Tomorrow is going to be absolute value inequalities. So just be aware that there's going to be a lot of similarities to that stuff. But the absolute value, or like the definition of absolute value, is distance from zero. So we did a little bit, I want to say back in like chapter 2 when we were doing this stuff with negative a and then like the absolute value of a. Do y'all remember that? And we just had like a number. Yeah. So we had like just like the bars, right? And we were saying like anything that's in the absolute value, when the answer comes out, yes, it's positive. So kind of similar, but these are going to actually be equations within there. Okay, whereas before it was just like a single number. So if we had something like the absolute value of x is equal to 4, that means that x can be equal to 4, or x can be equal to negative 4. It's like how far it is from 0. So if I had a number line, then to get from 0 to 4, obviously that's a distance of 4. And from negative 4, or 0 to negative 4, that's also a distance of 4. Now, my graph's not proportional, but that's okay. Okay, so it's 4 units away from 0. You have a question, or are you just holding your hand up? Yeah, 1 times 1 is 1.
He's talking about the
But that's
bars.
not written anywhere.
He thinks the bars that are 1.
Those aren't ones.
Who's laughing? I would never laugh.
That's a lie. I sound very close to laughing. Okay, yeah, I understand now.
Okay. Okay, solving an absolute value equation.
Yes, I am.
The equation, absolute value of ax plus b is equal to c, where c is greater than or equal to 0, okay, because whatever's in the absolute value ultimately has to come out being positive, or could be 0. So c has to be greater than or equal to 0, is equivalent to the statement, so basically equal to ax plus b equals c, or ax plus b equals negative c. Okay, that means what's inside can either be equal to positive c or it can be negative c. So, a little thing to help you remember, absolute value is 2 words. So each problem has two parts. Okay, so when we solve these, we're actually solving two things at the same, well, not at the same time. Solving two separate things within one problem. So as a little example here, just for a visual for you, if I have the absolute value of r minus 3 equals 9, okay, it's absolute value. I have two different problems. One of them is always copied down exactly, and that will be the exact same thing we do tomorrow. But then there's the other option is where it changes. So our first problem here is r minus 3 equals 9. But then the other option is this r minus 3 equals, and we change the sign of this. So this is positive 9, so over here it's going to be negative 9. Okay, if they started with the negative, then the other one's going to be a positive. Except for they really can't start you with a negative because we can't have a negative absolute value. So one's going to always be positive, one's always going to be negative, and then we solve these two things individually. Okay, so over here I add 3 to both sides, and I get r equals 12. Over here I add 3, r equals negative 6. So r equals 12 or r equals negative 6 would be solutions to this problem. And we could plug both of these numbers back in here, and we will get out a positive 9, whichever one we plug in. So you can check it that way to make sure that you did it right. Okay. I won't check a lot of the ones we do. I'll probably check like 1 or 2 of them here and there so that we can see it, but just for time. All right, so let me see. I'm going to write this too. All right, absolute value can never be negative. If an absolute value equation is equal to is equal to a negative number, then the answer is no solution. So that's why I said up here, this could have not been a negative 9 to start with, because that wouldn't even mathematically be possible. All right, so let's jump into some examples out of the homework section. So first of all, super easy one. I'm only going to do one like this. Number 4, the absolute value of y equals 36. Okay, so just like when we had this one that I did up here, the first time it gets copied down exactly. So y equals 36. Notice the only thing that's different is I've removed the absolute value bars. Then the next time I do it, again, the absolute value bars are removed, but what it's equal to becomes negative. So y equals 36 or y equals negative 36. Okay, so if it's just the absolute value of a variable is equal to a number, it's whatever that number is in the positive and negative form. Okay. Now, let's get into some that actually have stuff involved with them. Number 10, the absolute value of 4n minus 5 equals 18. All right, so this one of the first things, always make sure whatever this is positive before you start doing anything else with it. So copy down exactly without the absolute value bar. So 4n minus 5 equals 18. Or over here, the other option, 4n minus 5 equals negative 18. And then I just work them each individually. So I'm going to start with the one on the left. Add 5. So I get 4n equals 23. Then divide by 4. So n equals 23 over 4. So there's one of them. Over here on the other one, I add the 5. 4n equals negative 13. And then divide by 4. N equals negative 13 over 4. And so those are my two answers for those problems. All right, 12. The absolute value of q plus 8 equals 2. So 2 is positive, so I'm good to go. So how do I set these up?
Q plus
Remove
8
the absolute
equals
value
2.
bars for the first one, and then make 2 negative for the second one.
So q plus 8 equals 2, and then q plus 8 equals negative 2. So what is the left one? Q equals what?
2 equals negative 6.
And the right one?
Q equals negative 10.
Yep. So those are your two answers there for that one. Let's see, 16. 4 times the absolute value of b minus 1, and then outside of that, minus 7 equals 17. So, something different about this one compared to these last few that we have looked at is before I can set them up as two separate equations, I have to completely get the absolute value by itself. Okay? So it's almost like treating, you can just sit right there. Thanks. It's almost like treating the absolute value as if it's just a variable. Okay? And we're solving for that variable. Okay? We're solving for the absolute value. So the first thing I'm going to do is add the 7 over. So I have 4 times the absolute value of b minus 1 equals, what is that, 24. Now, I still have something outside the absolute value. It's 4 times the absolute value, so I'm going to divide by 4. So the absolute value of b minus 1 equals 6. Now, at this point, this looks like the previous problems, so I can split it up. So copy it down exactly without the absolute value bar. So b minus 1 equals 6. Or b minus 1 equals negative 6. So what does b equal on the left?
B equals 7.
And on the right?
Negative 5.
Yep, so b equals 7 or b equals negative 5. Obviously, it can't be both at the same time, but it's either or. The book just does the answers with little commas between, so it's fine. Let's see, 18. 7 over 4 times the absolute value of 3j plus 5, and that's all in the absolute value, and then plus 1 on the outside equals 15. All right, so absolute value is not by itself, So I need to get it by itself first. So the first thing I'm going to do is subtract the 1. So I've got 7 over 4 times the absolute value of 3j plus 5 equals 14. Now, I cannot distribute into an absolute value. Okay, absolute value symbols don't work like parentheses. So I need to multiply, by 4 over 7 on both sides. So normally, obviously, we haven't been writing that, but I just want us to be able to see it. So this stuff cancels out over here. Over here, 7 and 14 will reduce. So, so then I get 2 times 4. So I have the absolute value of 3j plus 5 equals 8. Now, I didn't mention this in the last one, but at this point, this is when we care that this value is positive or negative. Okay? So, obviously, I want it to be positive. I don't want it to be negative. If it was negative, it would be no solution. Right there. Thanks. So, it's positive, so I'm good to go. Because sometimes up here it may start out negative, but by the time I move everything around, it ends up positive. So I care about it once I get to the point when the absolute value is by itself. So copy down exactly 3j plus 5 equals 8, or 3j plus 5 equals negative 8. So subtract 5 over here. I have 3j equals 3. So then j equals 1. Over here, 3j equals negative 13. Subtracted the 5. So then j equals negative 13 over 3. So those are my two answers. J is 1 or j is negative 13 over 3. Both of those would make that statement true. Let's see, 20. Negative 3 times the absolute value of 5g plus 1, and then outside of that, minus 6 equals negative 9. So this is one like I was mentioning earlier. At the moment, this whole thing is equal to negative 9, right? Which, if it was just the absolute value is equal to negative 9, it would be no solution. But I don't know yet if I can do it. I'm going to move the stuff around and get the absolute value by itself. And then as long as it is equal to something positive, I'm good to go. So what's the first thing I'm going to move?
Plus the 6.
Add 6. So I have negative 3 times the absolute value of 5g plus 1 equals negative 3. Now what?
You add 3. You guys got this. I believe in you.
All right, look, this is negative 3 times this, so how do I move it?
You move it to the right.
You divide.
How do I? Yes, I divide. Okay, to undo multiplication, we divide. So I'm dividing both sides by negative 3. So over here, that leaves me with 5g plus 1. Negative 3 divided by negative 3 is 1. So positive 1. So now, am I good to continue?
Yeah.
Yes, because it's positive. So, two separate equations, 5g plus 1 equals 1, or 5g plus 1 equals negative 1. So subtract the 1, 5g equals 0, divide by 5, 0. And then over here, subtract the 1, 5g equals negative 2, or g equals negative 2/5. And those are our two solutions on that. All right, now, so all of those ones in that particular section just said solve the equation. The next little pocket of problem says solve the equation if possible. Okay, now, just for reference, on a quiz or a test, I will probably say on all of them, just solve the equation. If we have something that's not possible, you will just write no solution. Okay, I'm not going to like tell you, because if I tell you that, then you kind of already know what the answer is. I mean, I'm not saying that all of them are not possible in this section, but several of them will be. So just be aware of that. So 24, I've got the absolute value of y minus 4, and then outside of that, plus 8 equals 6. So at first glance, I see that 6 is positive, so it seems like I'm good to go. But I've got something over here with the absolute value, so what do I need to do first?
Subtract 8.
Subtract 8, and what happens when I do that?
No soul.
So y minus 4, the absolute value of that equals negative 2. This is a problem, so this is no solution. Okay, this can't be negative. All right, so you don't have to like write that on your paper when you solve these, okay? Saying no solution, that's going to just come from the fact that you see that this is negative, okay? But I'm just writing this for reference for you when you go back. All right, let's see, 26. Negative 4 times the absolute value of 8 minus 5n equals 13. What do I do here?
Divide by negative 4.
Divide by negative 4, so I get the absolute value of 8 minus 5n equals negative 13 over 4. What now?
That's no solution, guys.
No solution, why?
Because it can't be a negative.
Can't be negative.
I know it seems repetitive now, but on the quiz you'll be glad.
Because this section.
Easy section you like.
All right, on this next one, I want you to try this one on your own. So 28 is negative 5 times the absolute value of 4 over 5w plus 6 is equal to negative 10. So take a minute and do that one. What do we get?
What? W equals negative 5 or W equals negative 10.
We agree? Disagree? Good. So we divided by negative 5, which gave us a positive 2 on that side, so I could proceed on this one. So then we did 2 separate problems. 4/5 W plus 6 equals 2, or that stuff equal to negative 2. Needed to subtract the 6 and then multiply by 5 over 4. So we got W equals -5, W equals -10. How do we feel about it?
Easy.
Easy enough. Did she say tired?
Yeah.
Yeah, she did.
All right. Your problems are
We should just take the
Chris,
correct
you
one
have like
right
20
now.
minutes to do this.
7 through 29 odd.
Oh, that's not bad. That's like
Seven,
13
nine,
questions.